Good morning, dear participants. Welcome back to day 2 of the BGS Irradiation Service Days 2021. Good to have you back. As you can see, we are starting out in English. Later, we're going to switch to German again, but there's some reason we do this due to you, our participants, who are a little more international, maybe for today's topic. So yesterday, we covered all, or maybe almost all angles looking at radiation sterilization, from technologies to regulatory, the challenge of ever-growing demand to best practice. Today our topic will be radiation crosslinking, so a totally different topic. Again, welcome back to you all. Welcome back Thomas Österreich as well, head of sales at Beta Gamma Service since 2015. How are you?
Yeah. Thank you very much, and you?
Very good, I'm good. So Thomas, can you give us a little overview of the company, Beta Gamma Service? Maybe not everybody is familiar with it.
Sure. First of all, good morning also from my side, and a warm welcome in name of the whole BGS to the Irradiation Days today. BGS, we have birthdays this year. It's 40 years. We are founded in 1981. Meanwhile, the growing for the company is that we have 3 sites in Germany, located in the south of Germany, southwest, in the middle of Germany. We have meanwhile 200 employees and working for 600 customers in 30 countries. But we have to say mainly in Central Europe. The markets we are working on are split between sterilization for medical devices, for example, for minimizing bioburden, for single-use products, food industry, etc., pet food industry, packaging industry, pharmaceutical, primary packaging. And the other part is the cross-linking part, what we are talking about today, and that means that we are modifying properties of materials or upgrading polymers. That means that we are generating a higher temperature residence or stuff like this.
Mm-hmm. So you created the BGS Irradiation Service Days. Of course, we would have liked to be with our audience in a nice venue, but due to Corona, of course, this wasn't possible. So why did you create this virtual fair?
Yes, we have still a need of explanation what we are doing for. It means BGS is an irradiation service provider. It means we don't have any products or assortments by our own, so we receive products and materials from our customers, and we do it with our irradiation technology, sterilization or cross-linking. That means finished packed products, or for example also like cables, tubes and pipes, stuff like this. And for that we need to have the conversation. When you see the sterilization, for example, it's a very complex process. You need to explain, you need to organize, and there's a lot of regulatories also in the behind. And when it comes to cross-linking, it's still a largely underestimated technology with a lot of opportunities. I would like to say, to tell a little story. When I started at BGS in 2015, one of my dear colleagues, who is also taking part today here, had a very interesting approach. He said to me, if you want to understand our main businesses, that means sterilization is a kind of must. Cross-linking is a big chance.
Okay.
And that's the thinking behind. And for that, I would like to invite you to be inspired about all the possibilities this technology involves.
So yesterday we had the must-haves. Today we have the chances. Let us look into what's going to happen today. What can our participants expect from today's live conferences?
Yes, we have technical presentations and a numerous of application examples for cross-linking today. We created this program together with our long-term partners coming out of association research and the industry. So that means we will have a look to trends, mega trends in today. It means e-mobility, digital printing, all these things, and we have also some discussions, and we also will have a look to possibilities when it comes to materials.
Okay. Do you have a personal or a highlight you want to point out for today's program?
Yes, definitely. I think our digital tours, we had the experience yesterday how many participants take part of these digital tours. During these digital tours, you have the chance to have a look inside of our real plant to see technology, warehouse arranging, logistics, and to get some information by our plant managers as well. So please take the chance. There will be one at 10:30 in English, and there will be one in German at 1 o'clock.
Wonderful. Thomas Österreich, thank you
very much.
so much. Thank you for the introduction for today's day 2 of the Irradiation Service Days from BGS. A few hints: you might use our platform to get in touch with our experts. You can use the chat button for this, and then there's a chat form that you please use for your questions for the running presentations and our discussions that are going to happen today. As mentioned, ladies and gentlemen, today will be all about radiation cross-linking exclusively, materials, methods, applications. As we are facing a digital and sustainable transformation, new materials are of growing interest, of course. What if we can replace metals by plastics? What if the consistency of new materials match or even surpass the quality of their heavier and energy-intensive predecessors? If new additive production methods challenge the status quo? In the next hours, we will provide basics and outlooks in the field of radiation cross-linking in presentations, in discussions. So you are, as mentioned, invited to both participate and to be a part of the discussion with your own questions. So, as the world progressively turns its back on fossil fuels in order to at least get closer to fulfill the Paris climate goals, the demand of individual mobility is on the rise as well, due to growing populations and the development of civil societies worldwide. It's clear we need alternative drives, but new solutions, new materials as well in electrification and beyond. It doesn't come without challenges, and what the requirements are, what the current developments are, we will be talking with the keynote now, first of all, and then discuss a little later with Professor Ulrich Bruhnke. Welcome. Professor Bruhnke, he is a, may I say, automotive veteran with 40 years under the belt.
42 years.
42 years. A veteran is not meant in a sense of age, but experience. Okay. So he really...
Old brooms clean well.
True.
But the old know where the most dust is.
Yeah, that's true. So he's been in the automotive sector all his life in leading posts at Mercedes, AMG as CEO, BMW M CEO, and today Professor Bruhnke is CEO of TechMec AG. You'll probably talk about that in your keynote a little bit. And among many other fields and activities, he's also a lecturer in car body technology at the University of Stuttgart, meaning that you know a thing or two about automotive and construction and about the challenges that are ahead and what cross-linking may do to solve one or two problems in the field. Please, your keynote. Enjoy, ladies and gentlemen.
Thanks a lot. A very warm welcome also from my side. Let's talk about automotive business. Challenges of e-mobility for components and materials. Let me start with a pun. In Germany we say, do you have Benzin im Blut? I translated it and said, have petrol in your blood or kilowatt? Are you electric driven or do you think about combustion engines? I'm a passionate automotive developer. My friends call me a caraholic. Let me show a bit of my CV. I studied mechanical engineering at the University of Stuttgart and entered to Daimler in 1979. Was responsible for several different developments, also for interior, for car body design, for the whole car development, for ANC glass, chassis development, and then I had one of the dream jobs in the automotive business. I became president of Mercedes AMG, later of the BMW M. That means I had the chance to develop all the sporty and high performance cars in our automotive world. In 2005, I became professor at the University of Stuttgart. I'm teaching students since 1998. And it makes a lot of fun to show young people the chances and the possibilities regarding the development of automobiles and cars. Today, I work also for the president of Germany in the so-called Deutscher Zukunftspreis, the award for innovation and science and technology in Germany. And I also have to, as member of the jury, to give my vote and to say which is the most important new development between 30 new technologies per year. And what's maybe interesting too, I work also for a small company in Austria. They are developing a serial hybrid system. Let me show you that a bit later. If you have any questions, you see my contact data, send me a mail, and I look forward to talk to you. Let me show what caraholic means. It's my favorite car. It's a Pagani Zonda S. And you see there is written to Michael. Michael is Michael Schumacher. It was a special gift from Horatio Pagani to Michael Schumacher. But what makes me a bit worried is it's only 10 centimeters in length. It's a small model. But this is definitely my favorite car. It makes a lot of fun to drive it on the highway. It runs more than 330 kilometers per hour. The last big change in mobility was round about 100 years ago. And let me say, we are facing today a great revolution. But let's have a look back. In 1900, these pictures show a traffic situation in New York City. Where is the car? Do you see the car? The main transport was done by horse-drawn carriages. 13 years later, where is the horse? Within 13 years, there was a big move between one car and one horse in a traffic situation. Only 13 years between. How long will the transition to electromobility take? No one knows for sure, but one thing is for certain. Technological changes has accelerated massively. Let me show a few examples. To make a measurement about that, it makes sense to say how the number of years to reach 50 million users. If you look at the airlines, it took 68 years until 50 million users used an aircraft. In the automotive business, it took 62 years. The telephone took 50 years, electricity 46 years, television 22, the ATM, the PC 40 years. Now it speeds up. The handy took 12 years, internet 7 years, iPods 4 years, YouTube 4 years, Facebook 3 years, Twitter 2 years, and a little game 19 days. Let me give you an overview about propulsion systems. It looks difficult, but it's easy to understand. If you look on the left, you see energy supply. How to get the customer the energy? If you look at electric-driven cars, electricity, it's a plug-in system. This can be used for plug-in cars, for serial hybrids, for fuel cells, and also for battery electric-driven cars. If you work with the energy fuel, you have the combustion engines. It's also used in the plug-in hybrids, in the serial hybrids, and can be used in the fuel cell. If you have gas as energy supply, it's for gas propulsion and also for fuel cells. The storage can be done by a fuel tank, by a gas tank, or by a battery. And what happens on board? The serial hybrid has a combustion engine to produce energy on board. The fuel cell makes the electric energy coming out of the fuel cell. Do you have still propulsion engines? Yes, in the combustion-driven car itself, with a gas propulsion, also with a plug-in. But the electric motor drives the car. This is important to understand what happens to the design of the car body and the packaging of the car. Let's have a look at the architecture of different vehicles. This is a standard plug-in hybrid. What do you have? You have a combustion engine, you have a gearbox, you have two powertrains. You have to install two powertrains. That means you have also the weight of two powertrains. You have the costs of two powertrains. That gives us the target to reduce the weight in the car. You see still the architecture, it looks like the Alps. If you compare that with a serial hybrid, for example, done by Obris, the company I work for, you see in the front a small engine that produces the average energy. In the back, there is a small battery, only 17 kilowatts, and a 100 kilowatt electric motor. That means the high performance, the power to make acceleration is done by the electric motor. The average energy is produced by a small two-cylinder combustion engine. It's low-cost design. What you see at the picture is about 50% of the costs of a battery of an electric-driven car. Interesting is also the fuel cell, but low temperature, high pressure, difficult to reach the crash performance which is needed. And if you ask my personal mind, I say that's a very interesting solution for trucks, for buses, but not for a standard personal car. Many people think e-mobility was founded by Tesla. He is the inventor of the electromobility. It's not correct. It's Porsche. If you look at this car, designed in 1899, it was still a Porsche. And if you go to 1971, there was also a very famous electric-driven car. It's the first car on the moon, was an electric-driven car. But can an electric-driven car give you the emotions of a Pagani Zonda? If you look at this picture, maybe you never have seen it. It's the S-Park Owl. And if you see the data, they look unbelievable. More than 2,000 horsepower, 2,000 Newton meters of torque, 1.69 seconds from 0 to 100. I think this could be, in my eyes, a very good alternative to the famous Pagani Zonda S. The electric-driven cars require a modified vehicle architecture. Which are the possibilities? What are the chances? If you look at this car, you see the onboard charger in the rear, could be also installed in the front of a car. The electric drive module in the back, another electric drive module in the front, and the lithium-ion battery. This shows also the chances for the new design, but also the challenges. If you look at the big battery, in the crash situation, you should never have a short circuit because it's a high density of electricity. And if you get a short circuit, it becomes very dangerous for the passenger. That means you have to have a very stiff and strong body structure, and this creates additional weight of more than 500 to 600 kilograms in total. If you look at the design, it looks pretty good. It looks modern. You have in the interior variability you never had before. But let's have a look at the weight of the cars. When I was a young student, the VW Golf entered into the market after the Beetle. It was the first generation of the VW Golf, and the total weight was 770 kilogram. The next generation, with better crash performance, had 903 kilograms. The next additional 70 kilograms. Next generation raised up to 1,217 kilograms. And the Golf 8 now is more than 1,300 kilograms. And if you do the switch to the ID3 of VW, you see additional 400 kilograms. That means at a range of 400 kilometers, the extra weight of the battery compared to petrol is 420 kilograms. That's the reason why weight saving is a highly important issue regarding the development of the new generation of electric-driven cars. This is the absolute challenge. Maybe you know there was a deux chevaux from Citroën, and Chrysler developed in 1997 a composite concept vehicle, CCV, or deux chevaux. It was made of plastics. It was not stiff. It was soft. And we German engineers said they don't need a damping system. They can put the wheels directly on the car body. It's so less in stiffness that you need no suspension. But I ask, is such a concept with the radiation technology possible or conceivable? I'm interested in looking into the speech of my successor, Mr. Ostrovicki. Thank you.
Thank you so much, Professor Bruhnke, the true carholic. I keep that in mind. That's a good thing. And by the way, if you make it in 1.69 seconds from 0 to 100, you don't need Elon Musk anymore or Sir Branson to take you to the orbit, right?
No.
The feeling is approximately the same, I guess.
If you rise up a hill.
Thank you again for your presentation.